Hello and welcome to another free code session. My name is Jason Bach and all is well, I think, possibly. I kind of panicked a little bit in the last episode because I didn't have everything set the way I thought I should. But I went through and updated stuff and I think it's okay. I still don't like that we have to cast like this because, well, okay, to be fair, I kind of get it now. Because we're not deriving from adornments, we're deriving from this. And I don't think you can actually say, just derive from adornments. I don't think that will, it won't let you do that. Oh, would that be so cool if you could? I think there's actually something in type theory or with that area of research that you can actually have languages that do that, but I forget what that's called. So actually that now makes sense. I get why that doesn't work. I would almost wonder then if you would say here that, what would happen? Let's just go down an experimental path here. Oh, do we want to do that? No, we don't. And the reason why I'm almost positive we don't want to do that is because we keep constraining the adornments to a type so that we can get the members that we want. So if we did that, I don't think then that means that you're actually like overriding these things and then they don't actually come out to be the type that you want. So it's got to be like this. But because you're not technically inheriting from them, you have to say, well, I know I am of this type because of the way the constraints and everything work. I know that I am a adornment because a adornment is me. And that is what I am. So, but it doesn't understand that adornments is what you're inheriting from. So I kind of get why you have to do the cast. But what I also did was I wrote the code dump to be doing a little bit more calls just to make sure that what they're returning, which I changed to that they're all doing casts, would actually work. And so I added it to the program here and it runs. There's no like null reference exception. There's no invalid cast exception. So good. I'm still, a little leery about all this stuff, but I think we're going to move on. So the next thing to do is let's actually get a list going. I didn't do that in the last one. So what do we want to do now? We want to change in where we're returning a specific adornment type to a adornments for or something like that, because they are plural. Yeah. And then we say handler of member identifier. Now, that doesn't keep how we figure out all the generics. That's just a note to me. And the reason why is because I think the way I'm going to do this is I'm just going to do that, then have a section in there to say generate all of the custom adornment types. And then if there are events, change the event generation to only do one pass, plus the special intermediate interface that all of them will derive from. Okay, I think that's a general plan. So if I come back here, let's close all this out. And I believe the only places in the create that I have to worry about are like in the method builder. So if I come down here, here's the adornments type. How do we get the adornments type? Now, we're also using this. Yeah, I forgot about this. Well, I remember, but I forgot to put it in the list. We're using this because we need to, we use this for the event generation, if I remember right. And so if I come into events builder, event extension builder, that's it. And so that's where we have this tuple type coming into play, because that adds all of those and we're adding them to a tuple. Now, maybe we can hijack that and use it because we want to use the adornments type eventually. That's actually the base thing that we want to have. Okay. And we also want to capture the extension constraints because, no, we don't, because the adornments type will be closed. Although when we start adding open generics, that's going to be a fun one because that's going to spread to a whole bunch of different places. But hopefully we can do, that will just fall in naturally with what we're doing here. That probably didn't make a lot of sense, but there's a feature that I want to add where I want to support open generics. And I think it should work, but then it's going to change potentially a fair amount of implementation code and where constraints go. So we'll see. But I think I can use this when I generate them, because what I'm going to do is basically maybe not use them here, but use them when I'm generating all the types for the adornments. And essentially this for each is going to go away. We're only going to do this once, and we're going to constrain. There's going to be a type arguments here. Oh, that'll be interesting. That will be very interesting because type arguments right now is just a string. And I believe, yeah, we're using it down here for the handler as well. So we're going to have to be a little cute with that because we're going to need to put in a constraint for the this here to be of a certain type. If you go back to my mock code dump down here, we add that there. So, and then we do this as well. So we're going to have to be a little bit smarter than that, but one step at a time, one step at a time. Although it's good to think about what's coming down the pipe, so to speak. So what we can do here, though, is we are not going to use this here because at this point, we wouldn't have generated the code for it, the actual type definition for it, but we're assuming that that's going to be in another step. So what we could say here is hiding, we'll put that, okay. Adornments for. Now this, I had to think for a second. We do, I believe, have the name, the expectations fully qualified name. Yes, we do. So we're going to want that here dot adornments for, and then we want to say handler, and then do we get the, this is for a method. Oh, because we're on a method, so we can use that. Okay. Member identifier. Cool. And so we no longer have the adornments type here because we're assuming, well, okay, we want to do this dot adornments. That might get, yeah, because there's adornments over it, but that's fully qualified. I just remember we actually have a type called adornments, but these will be, this is fully qualified, so that should be fine. That shouldn't run into a problem. So we can do that here as well. And then I love the new target type new because it knows it has to be of that type, so it'll just make it, which is awesome. Else, we can say it's going to be that. Perfect. That's one of them. Got to start somewhere. And so we have the method, we have the property, and we get the member identifier. Okay, cool. So here, we're not putting in the adornments type. We're going to say member identifier like that. And then the same thing for the setter. Perfect. Okay. And do we have an indexer one? Yes, we do. So we do the same thing here, and that is a member identifier because reasons. And then up here, we put that there. If else, and there's no else and if, right? And then the setter has to have the same work done too. So for generated with defaults, we do that. And where do we put the name of the, oh, up there. Okay. Now that's great. It's all wonderful. But we've lost something. The thing that we've lost is in the pipeline, the identifier, because we need that now. So we're going to want to do, I think, a little bit of refactoring here. I think this is getting a little bit too hard to follow. And what I mean by that is if I go into the mock type builder is, oh, is that in the mock builder itself? I forget. Yes, we define the thing here. Okay, unpin, go away. What we're going to want is a type in create called like adornments pipeline. Adornments pipeline. We can make this an internal sealed record. And what will be in it? Basically these things, except let's make them fully qualified name, type arguments, constraints, and then let's put in a uint member identifier there. Now this will break up a couple of things when we do this. So we want to say new. And of course, we now want that, a hash set of that. And so we'll say, we want to do this regardless. So we're going to want to change this now. So information. So we probably can just do that and then get rid of this. Why are you... Lambda expression can be removed. Why? What does it think this is? It thinks it's a func. Oh. So what is this now? It's still a func of that. I don't want you to do that. Let's just say that. Now what's the problem? Oh. Now it's good. Okay, it's an action. Now that was cute. So now here you can see there's things that are breaking, and so, which is fine. We want this to be an action of this, and so where does that break it? That breaks it here. But when I was doing this, I kind of thought I should really change this because it felt kind of wrong, and I'm paying the price for it now, but that's okay. So we'll say new, and we also need the member. Where's this? Where are we? We're in method member identifier. Boom. It does break stuff, but because of, you know, the ability to do those things, it actually is not too bad. So we did that one. There will be this one. And then, yeah, we're going to have to get to that in a moment. Okay, so we do this. That breaks those. Let's just go through these. And then what did we break here? Well, okay, fine. Since you're being persnickety, I will change all these like that. And what did that break down here? I already passed it. Right here. Okay. Because you should be this. And then you should be this. New. And then member identifier. Cool. And then up here, we have the build setter because that got changed. So we do that. And then we do that. Thank you, IntelliSense, whatever you are. Okay, so we got that. We got some up here that we need to fix. Well, actually, this is the big one. So we got that one fixed now. Let's do indexers. Let's change that one. All the refactorings today. So we change that one, and we'll change getter and setter. And new. You don't give me the help on that one, do you? It is. Oh, sorry. It's like, what? Huh? I forgot I had a local method. Same thing here. So this has to change, and this has to change. So then this becomes that. Perfect. And it's just that easy. It is just that easy. What about the explicit properties? That has to change to this. And does that break anything in here? No, because we already use those and we're just saying that. Okay. So we're good there. And then this, well, we're going to have adornments. There's no way around it because we had to have handlers. So you got to have adornments. Okay. What we want to say here, though, is, are there events? So that's where this changes. So we have on the type mock. Wait, what? Mock type. Sorry, mock type. If on the mock type we have events, then we do this. Now, what we also want to do, though, is have something like mock adornments builder. No, build. We give it the writer. Sure, we'll give it the mock type just as a default. And then we'll give it the adornments because that's just a hash set of those things. And we could say to immutable hash set. Perfect. Okay, so we don't have that. Now we need to create that. What's a good one to do that from? Event extension. Probably that one. Let's copy that one. Event extension builders. So, no, you're good. You, though, need to change to, what are we calling it? Adornments builder. Okay. So now we'll have that. We take those things. We take those. This will be an adornments pipeline. I don't like it that it's just fully qualified names. Pipeline information. I mean, it's a little wordy, but that's really what it should be. If I come back up to here to the type builder. No. The mock builder. Let's change that to that. And then that's going to mess things up if I change it because we're capturing it here. Naming is hard. Naming is hard. So what do I want to call these? Adornments pipeline, because I call it a pipeline because I'm feeding information into it as we go along and do things on the adornments. Maybe if I just say, well, they're not FQNs anymore. They're just that. And then let's change that to adornments pipeline. Yeah, that's better. Why are you complaining? Oh, did I change? Yeah, okay. Okay, adornments pipeline. And we'll change that to adornments. Okay, cool. All right, we're getting closer. Still haven't unbroken everything, but we're getting closer. What are you? No, I don't want to use a local function. Go away. I get probably why it's telling me to do that, but it can go away. I don't want to do that right now. So coming back here, we are always going to generate adornments. We will only do this if we have events though. So if I come to here now, what I want to say is TODO. Need to create the intermediate interface. Need to create each custom adornment type. And that's it. Let's get rid of this because what I'm getting at is with this is if I go down my tests and I do like that, this is in here, but then somewhere down here, I know we do, or I do, well, I do that. Those are all there. I thought there was something that I did where I said, oh, it was the projections. That's right. If I made something that was, if I made projected type, I made them projections. And so this is right. So if I come, okay, sorry, it took me a second. What I want to do is something like this, similar to projections, like internal static class adornments. And then we need to create the internal interface, intermediate interface, and then each custom adornment type. And then here, what we want is, we no longer need this because like I said, but what we do need is adornment, intermediate interface, FQN. And that goes away. Well, if we would code it right. And so that goes away, that goes away. This now would have this here, because if I go back to my code dump and I look at these, no, I'm sorry. I say T adornments, raise that. And this is where I'm going to have to be a little bit cute. Do I care? No, I don't. I don't care about type arguments. And then this actually becomes the adornments. Take a drink every time I don't do this right. And then I say here, I just realized something. What's going to break this is there are cases where I think the event args actually have type arguments. But, and so then there are constraints. Like if I look at the events and I look at the event model and there's something I know I just missed here because the type constraints, those were coming from every not handler. Those were there. I don't think they showed up in this example. We just say that I have an explicit interface as one. I'm trying to see if I ever had a case where, at least in my tests here, and it doesn't look like I do. So I'm not sure. It had to be there. And so there had to have been a reason why I did that. And so I'm going to put that in my notes and say, why did I have type? Well, I think I had type arguments because I was putting the generic adornments there. And if one of those was open, we had the type arguments from there. And we had the constraints from there. There's something that's really concerning me here, which is, why did I have to pull these through before? I'm going to stop here. I really just need to stop here because I've been babbling for a while now. I am really concerned that I missed something. I missed that these are coming through. And even if I use this, for example, if I use this here, and of course there's also projected adornments, which won't fit this because they don't reach. God. I think I'm going to have to start over with this one. What I just realized too is, well, I can undo all the stuff I just did within rocks and rethink this from scratch. This sucks. This really sucks. I didn't take into consideration all the cases that could come up. And damn it. Oh well, you learn. If you're wondering what I'm complaining about, it's just that I don't think I took into consideration not just the projected types, but also the problem that if we have an adornment that needs type constraints, if I tried to make a custom type derived from that, how would I be able to have that flow all the way through? I don't know if I'm going to be able to make this work. And it sucks if I can't, because I'm back to square one with why is, that I know what's the problem with angle sharp, but I don't know how to fix it. Oh well, back to the drawing board. Thank you all for watching. Leave comments and questions below. See you in the next episode.